So, when you picture what's running ChatGPT, what comes to mind? Probably some crazy, futuristic, super complex network of systems, right? Well, what if I told you the core of it all is something surprisingly old school? In this tech bulletin, we're going to pull back the curtain on the database that somehow keeps one of the biggest AI services on the planet online.
800 million. That's how many users ChatGPT is juggling. And the powerhouse behind it? Get this. A single primary instance of Postgres. Yep, you heard me right. Not some bespoke, hyper-distributed system built from the ground up, but a good old open-source database. And let me tell you, they pushed it to its absolute breaking point.
An unlikely powerhouse indeed. I mean, think about it. In today's world, all you hear about is distributed systems and sharding, where you split a database up across a ton of different machines to handle massive load. So the idea of running a service this huge on a single primary database, it just sounds wrong. It's totally counterintuitive. Sure, it's simpler to manage, but you're putting all your eggs in one basket. You've got a massive bottleneck and a single point of failure just waiting to happen. And that choice, it set the stage for one of the biggest scaling showdowns we've seen in a long time. And this chart really tells the story. Look at that growth. It's not just growth, it's the speed of it. After ChatGPT went live, the load on their database didn't just climb, it exploded. We're talking more than 10 times the traffic in just a single year. You can just imagine the unimaginable pressure that put on that one PostgreSQL instance. The system was literally groaning, buckling under the weight of its own viral success. Okay, so cracks in the system. Because when you put that kind of pressure on anything, it's going to start to break. The architecture that worked just fine before was suddenly staring down a total, catastrophic failure. Millions of new users were flooding in, and the cracks were starting to show, big time. And here's where things get really nasty. They found themselves in this vicious cycle. A big spike in traffic would hit, right? That makes the database slow down, so latency goes up. Then requests start to time out. So what do users do? What do automated systems do? They hit retry, of course, and that just hammers the already struggling database even harder. It's a death spiral, a feedback loop that was threatening to take down the entire service. And we're not just talking about the site feeling a little sluggish. No way. These problems were triggering what the industry calls SEVs, severity incidents. And trust me, that's bad. A SEV is a high-impact outage that messes up the service for a ton of users. For a platform as big as ChatGPT, a SEV isn't just a problem. It's an all-hands-on-deck, drop-everything-right-now kind of crisis. All right, so the house is on fire, the scaling playbook. How do you possibly fight a fire that's literally being fueled by your own success? Well, the engineering team knew that just patching the holes wasn't going to cut it. They needed a real strategy. So they developed this incredible, multi-pronged playbook. It was all about taming the beast they'd created and building a system that could actually survive the future. And their whole defense plan boiled down to these three core ideas. First, protect the primary at all costs. That single database was the crown jewel. Second, isolate the noise. They had to stop one rogue feature from being able to take down the whole platform. And third, build smart guardrails. Basically, create automated systems that could handle these crazy traffic spikes without needing a human to jump in. So let's dig into that first one, protect the primary. The main goal here was super simple. Shield that one critical database from getting totally overwhelmed. The biggest move they made? Offloading work. All the read requests, just looking up data that's already there, they redirected those to a fleet of about 50 replicas. These are just exact copies of the main database. That one simple trick freed up the primary to focus only on the important stuff, writes, like saving your new chat conversations. And for the ultimate safety net, they had a hot standby ready to go, another perfect copy that could take over in seconds if the main one ever went down. Next up, they had to tackle what engineers call the noisy neighbor problem. It's exactly what it sounds like. Imagine one new super popular feature has some clunky code. It could suddenly start hogging all the database resources, and boom, the entire ChatGPT experience slows to a crawl for everybody else. So the solution was isolation. They split everything into high and low priority groups and sent them to totally separate database instances. So now some resource-heavy, low-priority task couldn't mess with a critical, high-priority request from, say, a paying customer. Smart. And part 3. Building those smart guardrails. This was all about creating automated defenses, like building a fortress to absorb those traffic shocks automatically. They set up multiple layers of protection. There was smart caching, so common requests could be answered without even bothering the database. They rolled out something called connection pooling, and this is a huge one we'll get back to. It's a technique for reusing database connections instead of wastefully creating new ones every single time. And of course, they put in aggressive rate limiting to just automatically say nope to excessive traffic during a massive spike. Okay, let's zoom in on just one of those guardrails I mentioned, connection pooling.
Before they did this, just opening a new connection to the database took 50 milliseconds, which, doesn't sound like a lot. But after they started reusing connections, that time dropped all the way down to just 5 milliseconds.
That is a 10x speedup, just from that one change. And that's the magic of scaling, right? When you are dealing with millions of requests every single second, a tiny little optimization like this doesn't just make a small difference. It has a massive, system-wide ripple effect on both performance and stability. It's a total game changer.
So, the big question, did all this work? Let's look at the results and what's next on the road ahead. Because the results are pretty staggering, but they also show that this kind of scaling is a battle that never really ends. First result? The system now handles millions of queries per second. Let that sink in. Millions per second. They literally took a system that was on the verge of collapsing and turned it into an absolute powerhouse.
And what about reliability? Well, they hit 99.9999% availability. In the tech world, that's the holy grail. We call it 5 nines. To put that in perspective, that means less than 6 minutes of total downtime in an entire year. For a service that grew that fast, that is just an incredible achievement.
And here's the kicker that really puts that reliability into context. Over the last 12 months, a period of absolutely explosive growth, remember, they had only one single major incident related to the database. That just proves how insanely effective this playbook was.
But, like I said, the work is never done. The team is still busy. They're migrating the last of the heavy workloads off the primary. They're working on something called cascading replication. It's a really cool technique where the copies start making copies of themselves, which will let them scale up to 100 replicas or even more. And yeah, they're looking at fully distributed systems for the long haul. It really drives home the point that scaling isn't a one-and-done thing. It's a journey.
So this whole story leaves us with a really big, looming question. OpenAI pull off an engineering miracle here, pushing a traditional database to its absolute limits. But as AI keeps growing at this exponential rate, can this kind of thing last? Are these heroic efforts going to be enough to keep up? Or are we staring at a future where we need a whole new kind of infrastructure, built from the ground up, to power what's coming next?